Hey guys, how's everything going? This is Jaser. This is the episode 2 from my series React Internals Deep Dive. I've touched this topic. It's about how React does the initial mount internally. 2 years ago, I've touched this topic by debugging. It's lengthy and I was not that clear about what is going on. And hopefully, 2 years later, today, I could explain it a little better. Let's begin. Here's the demo of a very basic React app. We're focusing on the structure here. This is a rendered result in a DOM. We want to know is that how React interpreted this code and get it rendered to the DOM, like with this link and this button. So a brief recap on the fiber architecture. I think I've mentioned this before, maybe somewhere. Anyway, the DOM world is what we care. We want to get it rendered and kept synced with the app state, right? So how React does this is that it maintains an internal representation of the app state, like a tree structure. It's called fibers. In the fiber tree, there are a lot of kinds of nodes. The first node, like the root node, fiber root node is, I don't think it's part of fiber tree, personally. The green ones are the part of the fiber tree. You can think of the fiber root node as like the sole entry point, the root of the root. Actually, the first node on the fiber tree is called host root, and it's set on the fiber root node with the current property. And what we mean by rendering is actually create a new version of these green ones, this whole fiber tree, and swap it with the old one by updating the current property on the fiber root node. So for all kinds of fiber node, like host root, function component, or forward ref, or lazy, or suspense, they all serve certain functions. One of them, some of them have the backing DOM nodes, like host component. Otherwise, they don't. Like function component, they don't have. The sole function component is what we care. It's about what it returns, right? And if it returns a host component like this, the host component has the backing node. So, this mapping, the fiber node maps to the DOM node, but it's not one to one, like suspense. It doesn't have a backing node, and it has served a different purpose by altering how the React traverse the fiber tree. Anyway, that's too far away from our topic today. Just remember there's an internal representation of the app state. There are some key properties on the fiber node. I think I can skip it for now. Remember the code we start rendering rendering the React app. We create a root, right? React DOM, something from client, create a root. And inside of it, we can see that the root create container, and it actually returns a React.root. And then inside of it, create fiber root, blah, blah, blah. So here's something interesting is that when we create the fiber root node, which is the red one, it will create an empty root node, which as is current. You can see it's set it. And also the root, the host root actually can access the fiber root node by the state node. So to get where the container info, where container is, because we pass the DOM node as a container, right? So this is the initial state, and then we will call the render, right? After we creating the root, we want to render it, and the argument is the React element, the sole element. It's not an array. I don't know. We can render an array now, but anyway, it's React element, React node. We render, it's called update container. One thing to notice is that actually the update is not kicked off instantly. It's actually enqueued and processed in another time. But we don't touch the details here. We only care about how the DOM tree is constructed. So just remember, an update is scheduled, and in a payload, we will get the argument. We will get elements. Basically, is the app in our demo, right? So that later we can know what to render. So this is the how the render is kicked off, and here becomes the performing concurrent work on root. I think we've covered this roughly in the overview. Perform concurrent work on root is actually the entry point to start rendering the whole fiber tree. But just remember that even though has the word concurrent in its function name, but it will fall back to the sync mode when necessary. Like initial mount is actually one of them because there's no point like deferring the rendering for the first time, right? When you're usually accessing your web app, I definitely want to serve the UI as soon as possible. So there's no way to pause and resume and making the process lengthy. Anyway, it's controlled by the lanes. You can find more details on what are lanes in React. So it fallbacks to render root sync. Inside of it, it's we only need to pay attention to two things. About one is prepare fresh stack, and then there's a while loop like work loop sync. And in work loop sync, it's pretty simple. It's like say when there is a work in progress, we'll perform unit and work on this in progress. So this is a because it's synchronous. It will work on it over and over again until the work in progress is null. So work in progress is also a very important keyword in React source code. It means like something we are building right away. As I mentioned, when we are trying to create a new version of fiber tree, this tree is already rendered to the DOM. So this fiber tree is prefixed with current. So this is the current fiber tree. This is current version of this fiber node. When we will try to re-render, we'll create a new version of this fiber tree. So this is called work in progress fiber tree, and the node is called work in progress. So yeah, just remember, work in progress is something we are building for the next tick, for the next render. So here, yeah, and if we update the work in progress, if we set it to null, it means that we will stop. If we updating to something else, it means that React Runtime will keep working on that fiber node. Great. So perform unit work first name, it means that we will work on it. Basically, we'll render the fiber node. And where is it? So yeah, inside of it, as I talked before, how React traverse fiber tree internally, there are two phases of doing the work on the fiber. Which one? The first one is begin. The other one is complete. Because of the tree structure, the begin work will like the rendering will be like a sort of a DFS way. So when we'll begin work, it will work on it, and then begin work on its child, and then until there's no child, and then it will start complete work. Complete means like when you are complete the node, the all your work on as a child, the child node must be completed already. So this kind of similar to the event bubbling system. So begin work is the phase one. So the next, you can see that if this doesn't return anything, it means that there's no nothing to work on. Basically means there's no child anymore. It will start complete. Otherwise, we'll set the next to the work in progress. As I said before, for this while loop, it will continue working unless the work in progress is null. So begin work is where the actual rendering happen. It depends on the fiber, the type of the fiber. As I said, there are some like codes I omitted here detecting if there's a change, and there's a bailing out logic. I've covered it in a different separate episode. So yeah, it depends on the types of the fiber. If the indeterminate component, it will do something like this. If it's function component, it will update function component. Host root, host component, host text, suspense component. There are many more. We will dive into the details on each part based on our demo. Great. As I said before, this is the work loop sync, and before it is a prepare fresh stack. It's just like you can think of it like a special begin work on the host root node. inside of it, you can see that it will create a work in progress root. This is the host root. It will do some initial setup. Yeah, basically that's it, I think. Oh yeah, it's set to work in progress to this root. So it means that the begin work, the while loop will work on the root in the next step. So in the next step, because the type is host root, here we will go to update host root, right? Yeah, host root, it will process update queue. Okay, this is the queue we set it. So the queue is cleaned up here. Yeah, and then the next child will be get retrieved from our argument we pass, like the initial app React element, and then you will call reconcile children. Reconcile children means like reconcile children is like a wrapper to do extra things rather than simply just ditching the old and creating new, right? In one, if you implement in a very naive way, you can treat it like just to ditch the old and just create a new version and replace all of them, but it's not performance. So inside of reconcile children, there will be much more than that. Maybe if it is array, it's try to reuse the fibers already there by looking at the key prop. If it is single, will do something. If it is not, it will do something else. But it's quite complicated. But anyway, after it will return the child. So this is what I said as a DFS fashion. It will go to the child to continue the begin work process. Reconcile children. Oh yeah, as I said, it's pretty. Inside of it is pretty complex, but initially there's a if branch. This is interesting. So if there's no current, it means initial mount. If there is current, it means re-render. As I said, the current means the current version. So when you are reconcile children of a fiber node, if there's no current version, you can just simply mount all the child fibers, right? And if there is already, it will call reconcile child fibers. Try to reuse them. Yeah, and then I think this is just personally, you can just keep the reconcile child fibers. This is logic. This mount is actually an improvement. This is because I think, yeah. Oh yeah, here's the difference. Yeah, what's the difference between reconcile child and mount child fibers? They are pretty much the same. You can see reconcile child fibers and mount child fibers are all the outcome from the create child reconciler. Only difference that the flag of should track side effects are not. Side effects basically here means that it means the DOM insertion. Yeah. So for mount child fibers, it means that we don't need to track the insertion. This is pretty reasonable, because let's say if you mount a fiber tree, you don't need to insert all the DOM nodes to the DOM directly, right? You only need to insert the root DOM node once, and it's done. So that's the improvement of mount child fibers over the reconcile child fibers. For updating like reconcile child fibers, you may insert parts of the DOM in the tree, but for the mount, you can treat them as a whole. So this is the sole difference here. And in reconcile child fibers implementation, inside of this reconcile child fibers, and inside of the reconcile child fibers implementation, it checks the child types. Like if it's one element, it will reconcile single element and then place it. This reconcile child fibers, yeah. And if there's an array, we'll reconcile child array. Remember, reconcile child array certainly will, when they are placed child, they will check the flag, like if we really need to place it or not. This is also important that you can see that there are two steps. First one is purely do the diffin, and then place single child means to mark the fiber node so that the React knows whether to delete it or insert it or update the DOM nodes in the commit phase. As I said, the whole rendering, said it before, the whole render can see the trigger phase, update phase, and commit phase. Anyway, so it's quite complex here, but just to remember the 2 steps. First, reconcile, and then mark. Here, reconcile single element. We will ignore most of the code here. So because there's no previous version, here we can see that it was just create the fiber from the element, and then you can see the set the return to the return fiber and return created. So you just created the fiber, and yeah, that's it. One thing to note is that when the fiber node is created, it's actually not a function component right away. It's indeterminate component because it might be something else, like class component or something. Place single child, as I said, it's purely gives the fiber node a flag, so that React could later knows what to do. So here you see that we're using this flag, right? So if this flag is true, means we need to mark it with placement. Placement basically means insertion. So our app here, the initial React elements, it will be indeterminate component, and begin work we will go to the branch of indeterminate component, and we will come to this mount indeterminate component. Because indeterminate, once it's rendered, it's no longer a mount indeterminate. It's no longer indeterminate component again. So inside of it, we will just reconcile child null, because it's definitely null. It means no previous version, and this will, as we mentioned before, it will be mount, right? Mount child children. When in mount children, there's no tracking of the side effect of the insertion. When we are rendering the indeterminate component, it could be class component or function component. Either way, we'll render the component and with the hooks and get the return value and continue. So you see that this is the value. Tag. We tag it with class component or function component, and we will reconcile children. The value is the children. So yeah, we will go down to the children inside of app. It's p div. So it's host component now. So in begin work, we will go to update host component. We'll do the same. Host component means I think it's the leaf of the fiber tree, right? The tree, because it has backing of DOM tree. Here is hydration. I have a separate episode. But anyway, we will reconcile children again. About current, work in progress. Obviously, current here, it's empty. Inside of it, it will go to mount again. So there's no tracking side effect. The only place, only place that its update is, it's very interesting. I need to point it out. It's like, remember when we are creating a here when we are creating the container, like the DOM root, React DOM root, we already created the host root there. So when we are re-rendering, starting from the newly created host root, the current version is not empty. So only for the first handling of the host root, we are not using the mount children, but update reconcile children is used. So that's where the only place child will be called. Like say where it is. Yeah. When we prepare a fresh stack, we will create new version of root. This one is not null. So when we are we would have one placement for it, and other than it, we will not tracking any assertion. Great. Okay, let's continue. Let's go to the host component, reconcile children. Yeah, it's the same. And we have 3 children inside of it, right? For p tag, there's a link. It's just a similar process to app. It's indeterminate component, and then it become function component. A and button, its host component, and we will go deeper to its text. But it's a slightly different for link and button, because the button use the text as an expression because it's dynamic to the count. But for link, it's static. So they have different process inside of React to the link tag. It won't have the children. It will the text will be treated as the text content, as the props of the DOM element. But for button, it will create a host text and works as its child. So you can see here for update text, it returns null, so there's no need to go down. There's nothing as it is child deeper anymore. It's basically nothing. But in the beginning work, but it will handle differently in the commit phase. So this is the begin work. As I said, it's the DFS fashion. When we are done for the first, the path to the when we were done begin working on the first pass to the leaf node, the React will start completing the nodes and then go to the discipline. So in the complete work, there's a check on the host component, and then it will create an instance. This is actually where the DOM node is created, and also there's a call append all children. So yeah, we need to organize the DOM nodes based on the fiber tree structure, right? So yeah, we need to put the child elements as the to wrap them up to the parent element. Yeah, that's basically it. And if for host text, it will create a task instance. Instead of DOM, this is actually a node called, I think, text node or something. Yeah. Oh, yeah. So what I said, the difference between the link and the button, inside of finalize initial children here, which is called here, yeah, finalize initial children, set initial properties, blah, blah, blah. You can see here, if the next property is string, it will treat it as text content. If not, because for a button, it's not a string. It's a variable or expression. No, it's a value. No. The prop is a string. Prop key is children. Next prop is string. Interesting. Oh, it's number, right? So for button, it's number. Oh, yeah. So it's not string. It's not text content. It will be treated as host text. Cool. So by now we know the work in progress version of FiberTree will be created in such fashion, and then the backend nodes are already created, but it's just not put in the DOM yet. And flags, yeah, flags. There's only one flag in the host root that will guide React to do the insertion. So it's time to go to the commit phase. To please go to the overview to see what the phase are. Inside of it is commit mutation effect. This is not effect; it's like internal naming for something that React will do to the DOM. So it's called effect. Commit mutation effect. Inside of it, just some recursion call. It makes sure that all the changes are on the children are done before the updates are done to the node itself. And inside of it is commit reconciliation effect, which actually has the insertion. Let's take a look. This one, deletion, commit reconciliation effect. Yep, here you see. We're checking the flags. If the placement is there, we will commit placement. Commit placement, it's pretty simple. It's just insert it to this parent. But there's only one insertion in our demo, which is on the host root. As we said, host root could allow us to get the container information by state node, which points to the actual fiber root node, which has the container information. And then yeah, we just set it and put it to the container, and yeah, it's done. After it, yeah, the final DOM is inserted, and the current on the React fiber root node will be updated to the new fiber tree, and it's done. And the next re-render after we click the button will be explained in the next episode, which is about how each React does the re-render. So here is a slide explaining things. So yeah, we have the call stack, scheduler, fiber tree, and host DOM. Let's see. So when we when we run the code, React DOM create root and render something, it will create a fiber root node. It has the container information, and it already has the host root, which is empty, and set it up, right? And then it schedule an update on this host root. Update queue, update. This is the React elements, and the scheduler will start working on the rendering, and then perform it, and then host root will be created from this host root, and it also has the update queue, and then it will be created an app, which is the element we get from this update payload. As we said, because there's no app in the fiber tree, so it will be placement. Oh no, because there's host root. For host root, it will be update child fibers, so they will be tracking the effect. So this app will be inserted, but other than that, you see there's only app. There's no current version of app, so it will be mount. There will be no tracking side effect. Great. And app, it will return a div. We go to div, go to p, and also 3 children link br button. We will go to link, and then got a. We got a. As we said, there's no child for a. The text will be treated as text content, so it will be completed. I put it a different color called complete. And at this timing, a DOM node of this host component anchor link will be created, and then complete is done. We'll go to link, and then link doesn't have a backing DOM, so it go to its sibling br. Br again creates these DOM nodes, completed self, and go to button. Button, as we said, it has its own children, like click me and this number. Oh, this children is array, so it will not be treated as text content. Anyway, this is a host text. They are all the terminus of this fiber tree, and then it will create a text. I don't add the like a rectangle here, add the shape here, so it means it's a text. Click me, and 0 also creates the DOM complete button. You see, when we create a button, we will add all this text under this button fiber node as the child, also as the child in the DOM world, and then we complete p. Also add all these a br button as the child of this p, and div, and then app is completed, host root is completed, and then we will start committing, right? Commit root, commit mutation effect. We will find the placement. There's only one placement, so we insert the div to the container by looking at the state node on host root, which is actually the fiber root node. Get it and append it. So the DOM, you see, it's done. And then we will just swap the old tree to the new tree, and then set the current to fiber root node, and it's done. So you can see that in the re-render, probably will do something similar, and create a new version and just do the swapping. And yeah, that's for the next episode. Great. Hope it really helps. See you next time. Bye.